Now we're going to start looking at graphs a little bit closer and looking at some of their characteristics. So the x-intercept occurs where the graph crosses the x-axis, and the y-intercept occurs where a graph crosses the y-axis. The graph of x equals a is a vertical line, and the graph of y equals b is a horizontal line, and we'll look at examples of all of that. So in this problem, they just want us to identify the intercepts from the graph. So the first one they want us to find is the y-intercept. Well, the y-intercept is where it crosses the y-axis, and it looks like it's crossing at the ordered pair 0, 3. Then they want us to identify the x-intercept, and that's where it crosses the x-axis, and that appears to be 2, 0. Now they want us to find the intercepts without graphing. So one thing you might notice from your intercepts is no matter if you're looking for an x or a y, the number 0 is always involved. So we're going to use that idea to help us find the intercepts without graphing. So I'm going to plug in 0 for x. And I'm going to find out what y goes with that. So 6 times 0 plus 5y equals 30. 6 times 0 is 0. So then I have 5y equals 30. You can probably already see what my answer is going to be. 5 times what's 30, and that would be 6. And if you didn't see that, you just can do one final step and divide. And that would get you y equals 6. Then we're going to turn around and plug in 0 for y and see what x we get, which would be the x-intercept. So 6x plus 5 times 0 equals 30. So we get 6x plus 0 equals 30, which 6x plus 0 is 6x. Divide by 6, and x equals 5. So those are my intercepts. 0, 6 would be my y-intercept, and 5, 0 would be my x-intercept. So when you're trying to find intercepts from an equation, I call it just look for your zeros. Plug in zeros and see what you get for the other variable. So now let's take this one step farther. We're going to find the intercepts just like we did in the previous problem, and we're going to graph. So this is a graphing method. Just like we were picking our own ordered pairs in the last lesson, we just picked our own x's and plug them in. We're still going to do something similar, but we're going to plug in zeros. We're going to be very specific. Instead of picking any number, we're going to pick zeros to plug in. So the first one I'm going to plug in, I'm going to plug in 0 for x. So that's 0 plus 2y equals 4. So that's 2y equals 4. Divide by 2. So it looks like y equals 2. So when I plug in 0 for x, I get 2. Now I'm going to plug in 0 for y. So I have x plus 2 times 0 equals 4. 2 times 0 is 0. And x plus 0 is x. So when I plug in 0 for y, I get 4. So now I can graph those 2 points, 0, 2, and 4, 0, and I can draw my line. That's a little off. Hopefully you're using a straight edge, so you get a nice clean line going through your points. Again, your 2 points that you create is a guideline for the equation because there's infinite points, infinite solutions on a line. So don't just connect the dots. Make sure that you draw your line through your points and put arrows on the end. Okay, here's another one. So we're going to graph using intercepts. So we're going to plug in 0 for x, find out what y is, and then we're going to turn around and plug in 0 for y to find x. So 4 times 0 minus 5y equals 20. 4 times 0 is 0. 0 minus 5y is minus 5y. And last step, divide by negative 5. So y equals negative 4. So when I plug in 0, I get negative 4 for y. Now I'm going to plug in 0 for y. So 4x minus 5 times 0 equals 20. 4x minus 0 equals 20. 4x minus 0 is 4x equals 20. Divide by 4. So x equals 5. So now I have 2 points, 0, negative 4, and 5, 0. And now I can draw my line. Put my arrows on the end. Okay, let's look at this one. Now they're not giving us a table, and if you'll notice, this equation is a little bit different than the last one. There's only one variable. If there's two variables, like in this problem and this problem, you're going to get some type of a slant line. In a problem like this, it's going to be either a horizontal or a vertical line. There's not going to be a slant to it. So the question is, how do you know if it's a horizontal line or a vertical line? Well, if it's x equals negative 3, that means it must cross the x-axis at negative 3. It has an x-intercept at negative 3. So since it's crossing the x-axis, then it must be a vertical line going through negative 3. So when it's x equals, it's always going to be a vertical line because it has an x-intercept, so therefore it must cross the x-axis. So what happens if it's y equals 4? Well, that means it has to cross the y-axis at 4, which means it must be a horizontal line in order for it to do so. So if it's y equals, it has a y-intercept, and therefore it's going to be a horizontal line. So those are the easiest kind of graph. You just have to remember, is it horizontal or vertical? And you really don't even have to memorize that. Just think to yourself, if it's y equals, it crosses the y-axis. If it's x equals, it crosses the x-axis. Now in this problem, there's still only one variable, which tells me it's either horizontal or vertical. And since it's x, that means it crosses the x-axis. The question is where? Well, what you're going to have to do is solve for that variable. So if I have 3x minus 15 equals 0, let's just simply solve for x, and then we will know where it's crossing. So 3x equals 15. Divide by 3, so x equals 5. So it's going to be a vertical line through 5. And that would be our graph for that equation. Now here's two problems where they give us lines and they want us to write equations, but these are going to be easy because they're horizontal and vertical lines. So since the top one is crossing the x-axis, then it must be x equals negative 2. And since the bottom one is crossing the y-axis, it must be y equals 3.